Hello. 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 Good afternoon, students. So today we will learn about matrices. So first we will learn about some basic information about matrices. So what is a matrix? First of all, matrix is an array of some elements arranged in rows and some columns like A11, A12, A13, so on like that, and A21, A22, A23. So you must have learned this in 12th standard or before that. Okay. So this horizontal line, what is this called? This horizontal line is called as a row. We will take a specific example like this: 2, 3, 1, 1, 5, 4, 3, 2, 2. Okay. So this 3, 2, 3, 1 is called a row. So a horizontal line is called as a row, and vertical line is called as a column. Column. So number of rows is so order. What is order of matrix? It is multiplication of rows, number of rows and columns. So first you have to write the number of rows. What is the number of rows in this matrix? There are 3 rows. Therefore you will write like this: 3 into. Also number of columns is 3. So therefore this matrix is 3 cross 3 matrix. So if we take other example like this: 2, 2, 1, 1, 3, 2. What is the order of this matrix? The number of rows is 2 and number of columns is 3. Therefore this matrix is 2 cross 3 matrix. You must have learned this before. So this is called as order of matrix. This is basic information about matrices. Now, you have learned product of matrices. What is product of matrices? We will take one example like this: 1, 2, 0, 0, 1, 2, 3, 1, 2. Okay. So when multiplication is possible, suppose the order of this matrix is 3 cross. Suppose this is Aij matrix whose order is 2 into 3, 2 cross 3, and another matrix whose order is 3 cross 4. So what is the essential condition for matrix multiplication? This particular number and this number has to be equal. Therefore only after that we can multiply two matrices. If these two numbers are equal, then we can multiply two matrices. That is what the number of columns in these matrices should be equal to the number of rows in this matrix. That is the only way we can multiply two matrices. Okay. So what is called an identity matrix? Identity matrix. So if we are considering a 2 cross 2 matrix, then what is identity matrix in 2 by 2? 1, 0, 0, 1 is identity matrix. Or if we are considering a 3 cross 3 matrix, then identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. This is identity matrix, and so on. We can calculate identity matrices of other. Yeah. Okay. So what is the essential condition here? The diagonal element should be 1 and all other elements should be 0. That is when we call that matrix as identity matrix. Okay. Then again, so what is symmetric matrix? Symmetric matrix Symmetric matrix is, suppose, 1, 2, 3, 3, 4, 5, 6, 7, 8. What is symmetric? Is it a symmetric matrix? No, it is not a symmetric matrix. When we call a matrix as a symmetric matrix, if Aij term is equal to Aj term. See, these two terms should be equal, then these two terms should be equal, and these two terms should be equal. Like this: 1, 2, 3, minus 2, minus 2, 3, minus 3, 4, 4. So this minus 2 and minus 2, minus 3, minus 3, and 4 and 4. These are equal. Therefore, we call this matrix as symmetric matrix. Okay. Then null matrix. What is a null matrix? Null matrix. Null matrix is nothing but all the entries should be 0. सगळ्या एंट्रीज जर 0 असतील तर त्या मॅट्रिक्सला काय म्हणणार? नल मॅट्रिक्स. नल मॅट्रिक्स. ओके. नल मॅट्रिक्स. Okay, what's a row matrix? What is a row matrix? Row matrix is if the matrix only has a single row, then the matrix is called as a row matrix. Similarly, what is a column matrix? If a matrix has, so this one is called as row matrix, and this will be called as column matrix. So the matrix which contains only single row is called as row matrix, and matrix which contains a single column is called as column matrix. So, okay. So what is the order of this row matrix? Is it's 1 cross 3 or 1 cross n. If we are not being specific, then it is, in general, it is 1 cross n. Now, what is the order of column matrix? Is n cross 1. See, in row matrix, the number of rows are 1, and in column matrix, number of columns is 1. Okay. So what is it now? A diagonal matrix. What's a diagonal matrix? We have already seen, I think. What is a diagonal matrix? 1, minus 4, 3. The diagonal entry should be non-zero. The diagonal entry should be non-zero. The matrix is called as diagonal matrix. See, diagonal entry should be non-zero. All other entries should be 0. Then it is called as diagonal matrix. Now we will see what is an upper triangular matrix. Upper triangular matrix. What is an upper triangular matrix? We will take a example of a 3 cross 3 matrix. What is an upper triangular matrix? All the entries below the diagonal should be 0. All other entries, whatever they may be, it doesn't matter. Minus 1, 2, 6, 7, 8, 9. That doesn't matter what those entries are. Only the entries that are below the diagonal. See, this is diagonal. The entries below the diagonal should be 0. Therefore, this triangle is called a upper triangular matrix. Similarly, we can understand what is a lower triangular matrix. Lower triangular matrix. What is a lower triangular matrix? All the entries above the diagonal. All the entries above the diagonal should be 0. All the entries above the diagonal should be 0. Like this. Okay, this is the diagonal. All the entries, these are 0, and all other entries should be non-zero. Then it is called a lower triangular matrix. Okay. Now we will see matrix. This is in transpose of matrix. See, this kind of examples on transpose of matrix will be in your exam. You will take a 2 cross 2 example. See, 7, 8, minus 1 and 2. Suppose this is A, matrix A. What is matrix A? 7, 8, minus 1, 2. Then A transpose, how it is written? A to the power of T. You should not say power of T, it is A transpose. So what is A transpose? The first row you should write it like that, like column, that is 7, 8, and then second row should be treated as second column, minus 1 and 2. See, for 7, 8, first row you should write it as a column, and then second row you should write it as second column, that is transpose of matrix. We are considering a 3 cross 3 matrix. Here about a 3 cross 3 matrix. What is the transpose of 3 cross 3 matrix? Suppose 1, 2, 1, 3, 4, 5, 7, 8, 6. This is matrix A. Then what is the transpose of matrix A? So as I said, the first row you should write it as first column, 1, 2, 1. Then second row you should write it as second column, 3, 4, 5. And third row should be written as third column, 7, 8 and 6. 7, 8 and 6. That is what a transpose is. Okay. So what you should do? You should interchange the rows with columns. Then you will find the transpose of matrix A. Okay. Next. Now, determinant of a matrix. Now we will learn about determinant of matrix. Determinant of a matrix. If A is equal to, we will take first example 2 cross 2 matrix. First we will take a 2 cross 2 matrix. Okay. Suppose the matrix is 2, 3, 4 and 2. What is the determinant of this matrix? We have to multiply this first. It is 2 into 2. 2 into 2. Then we have to subtract multiplication of this 2. 4 into 3 into 4. 3 into 4. So 2 into 2. What is 2 into 2? 4. Minus 4 into 3. It's 12. That is equal to minus 8. So the determinant of this matrix is minus 8. Okay. Now if we talk about 3 cross 3 matrix. What is determinant of 3 cross 3 matrix? 1, 2, 1, 1, 1, 2, 2, 1, 3. Okay. Determinant of 3 cross 3 matrix. First, you must have learned this in 11th standard or even before that. We will see how to find the determinant of 3 cross 3 matrix. What you have to do first? First, take this element 1. Then what you have to do? What is the position of this element? It is first row and first column. So position of this element is A1, 1. So A1, 1. The position of this element is A1, 1. What is the position of this element? A first row and second column. And what is the position of this element? A1, 3. Okay. So first we have to take first element A1, 1. That is 1. And we have to cancel first row, this first row and first column. First row and first column. What is remain? This part is remain. So we will take determinant of this. Okay, 1 into 3, it is 3 minus 2 into 1. 2 into 1, 2. Then we will take this element, but minus 2, minus A1, 2. Therefore minus 2. So we will delete first row and here we will delete first row and second column. So what we will get? 1 and the remaining part we should find the determinant. 1 into 3, it's 3 minus 2 into 2, it's 4. Then in the end we will take this element, last element A1, 3, that is 1 plus 1 and find the determinant of remaining elements. What are those elements? 1 into 1, 1 into 1, 1 into 1, it is 1, minus 1 into 2, it is 2. And we will solve this, okay? We will solve this. Remember, this should be taken as positive, element here should be taken as negative, and then again positive. If the matrix is 4 cross 4, 5 cross 5, then you have to continue with this trend, okay? This here plus, this minus, this plus, then again plus, minus, continue. See, okay, here 3 minus 2 is equal to 1, so 1 into 1 minus 2 into 3 minus 4 is equal to minus 1, plus 1 into 1 minus 2 is equal to minus 1. Therefore 1 into 1 is equal to 1, minus minus, plus 2 into 1 is equal to 2, minus 1. So 2 plus 1, 3, 3 minus 1 is equal to 2. So the determinant of this matrix is 2. So this will help you in finding the inverse of matrices. So most of the examples will be based on adjoint of matrix or inverse of matrix. Okay. So we will first, you don't have to follow the traditional method that is given in your textbook to find the A inverse. I'm going to tell you a simple method to find A inverse here. So, but what is the basic rule? 1 upon determinant of A. A inverse is equal to 1 upon determinant of A into adjoint of A. Okay. To find this adjoint of A, you used to do what? You used to find the cofactor matrix and all that. But here we do not have to do that. We will use a simple method to find A inverse. Just you have to find a determinant of A, and adjoint of A is easy to find. Okay. Now we will take some examples. Okay. First example. If A is equal to, a matrix is given here. Okay. A11, A12, A21, and A22. Then the minor of A11, it is asked. The minor of A11. That is what we have to find. We have to find the minor. That is what? M11. That is what we have to find. So what is here given? 1 and 1. So therefore we will delete first row and first column here. We will delete first row and first column. What is the remaining element? A22. Therefore the answer is this, D. Okay. A22. Next example. So here a matrix is given, matrix A, that is 1, minus 1, 2, 3. Then M21 we have to find. What is we have to find? We have to find M21. That is this. Okay, this here, what does it indicates? It indicates row, and this indicates column. Okay. So what is said here? Second row. So we will delete second row and we will delete first column. Delete first column, second row and first column. What is the remaining? Minus 1. So therefore M21 is minus 1. Option B. Option B is the correct answer here. Next example. Here matrix A is given, a 3 cross 3 matrix is given, and we have to find M23. M23, that is what we have to find. What is 2 here? It is row number, rows number, and this is columns number. Okay, this column, this number indicates row, and this number indicates column. So second row and third column. What is the second row? This is the second row. What is the third column? This is second column. So remaining elements we will write in determinant. Okay. So what is the determinant of remaining elements? That is M23. That will be M23. 1, 1, minus 1, and 2. Okay. These are the elements. These are the remaining elements that we wrote in determinant 1 1 minus 1 and 2. Now we have to find the determinant. Okay, what is the determinant? First we will do the product of this element. 1 into 2, 1 into 2 is equal to 1 into 2 minus this product of this element, 1 into minus 1, 1 into minus 1. Okay, 1 into minus 1. So 1 into 2 is equal to 2, is minus minus, it is plus, then 1 into 1 1, 2 plus 1 is equal to what? 2 plus 1 is equal to 3. Therefore minor is this element. Okay, option A, that is the correct option. Okay, next. Again, similar example, we have to find minor of the element A31. Minor of the element A31 means M31. That is what we have to find. So what is this? Again, similarly, this is row number and this is columns number. So third row should be dropped and first column should be dropped. What is remaining? 2, 3, 4 and 2. Okay, 2, 3, 4 and 2. So now we have to find the determinant of this matrix. So 2 into 2, what is 2 into 2? Maybe I write like this: 2 into 2 minus 3 into 4. 2 into 2 it is 4, minus 4 and 3 into 4 is 12. 4 minus 12 it is minus 8. So B is the correct option. Okay, now cofactor of 1 2. We will find the cofactor of A12. What is A12? A12. Now, in previous examples, we found minor of elements. Okay, minor of elements, and now what we have asked? In previous elements, we found out the minor of elements, and now in this example, we are asked cofactor of elements. Okay, you have learned this in 12th. Okay, what is the cofactor of elements? So suppose M11, we are talking about M11, and what is cofactor of elements? It is minus 1 raised to I plus j, okay, into mi. Okay, this is the difference between cofactor of element and minor of element. This is minor of element, and what do you have to do to find cofactor of element? You have to multiply it by this number, minus 1 raised to I plus j. So we'll find in this example. So we have given that A is equal to minus 2, 3, minus 3 and 5. Minus 2, 3, minus 3 and 5. And what we have to find? We have to find cofactor of A12. Cofactor of A12. First we will find what? Step 1. What we will find? We will find minor of A12. Minor of A12. What is the minor of A12? As we have seen in previous example, A12. One, this suggests row and this is column. In first row and second column. So what is minus 3? The minor of A12 is minus 3. But this is not our answer. Okay, this is not our answer. What is step 2? So this answer, okay, this answer is given in the exam as an option, but this is not the answer. Okay, how to find A? We have been asked A12. We have to multiply this minus 3 by this minus 1 raised to I plus j into sorry, minus 1 into I plus j, minus 1 into I plus j into M12. What do we write? Minus 1 raised to I. Value of I here is 1. Value of j is 2. And M12, what is M12? What is M12? It is minus 3 that we have already found. It is minus 3. That is what? Minus 1 and 2 plus 1 plus 2 is 3 into minus 3. So what is minus 1 raised to 3? What is minus 1 raised to 3? Minus 1 raised to 3 is minus 1 and this is minus 3. So minus 1 into minus 3 is 3. So that is correct option. Okay, is given as A. So correct option is A. You have to multiply it by minus 1 to the power I plus j. I plus j is this is entry, rows entry, and this is columns entry. So if this addition is odd, this addition is odd, then this will come out to be odd, my minus 1, and if this addition is even, then this is positive 1. Okay, if this is 2, then minus 1 square is 1. If this is 3, minus 1 cube is minus 1, and similarly like that. If the power is 4, then it is again 1. If the power is 5, then it is minus 1. Okay, next example. Again the similar example. Now we have given B. Matrix B is equal to 2, 3, minus 4 and 3. So cofactor A21. What is the step 1 here? Step 1 is we have to find minor first. Minor of A21. What is minor of A21? Then second row 2 means what? Second row. And this one, what does this one indicate? First column. So delete that. What is the remaining value? It's 3. Is therefore minor of A12 is 3. And then we will find cofactor. Cofactor of A12. What is cofactor? As we have seen in previous example, minus 1 raised to I plus j into m ij. That is the standard definition of cofactor of any element. That is minus 1 raised to I. What is I here? I, it is 2. Okay, 1, 2. This is I, is 1 plus j is equal to 2 into mij. What is mij? Is 3. 3. That is what? Minus 1 cube into 3. What is minus 1 cube? The power is, this is odd. Therefore, this value will be minus 1. Minus 1 into 3. That is minus 3. Therefore, the answer is minus 3. Okay. So we have seen some examples on 2 cross 2 matrices. Now the example is on 3 cross 3 matrices. The matrix is given. The 3 cross 3 matrix is given, and we have to find the cofactor of A32. What we have to do here? First, we have to find the minor of A1, A32. Minor of A32. What is minor of A32? Similarly, as we have done earlier, 3, 2 means what? Third row. Third row should be dropped here, and second column should be dropped. So what is the remaining part? It is 2, 3, 4, and 5. 2, 3, 4, and 5. So we have to find the determinant of this matrix. What is the determinant of this matrix? 2 into 5. So 2 into 5. 2 into 5 is 10 minus 4 into 3 is 12. 10 minus 12. What is 10 minus 12? It is minus 2. So minor of A32. Minor of A32. How do we write this? Minor, oh sorry, 32. No. 32. M32. It is written as M32. But that is not what we have been asked. M32. The answer is minus 2 is given here, but this is not the correct answer. It is given to confuse you. Okay. Now we will find the cofactor of A32. What is cofactor? Cofactor of A32. What is cofactor of A32? Similar what we have seen in previous examples. Minus 1 raised to I plus j into Mij. What is it? Minus 1 raised to I plus j. What is I plus j? 3 plus 2 into Mij that we have just found. It is minus 2. Minus 2. Let us write in bracket. Minus 2. So minus 1 raised to 5 into minus 2. You do not have to find this specifically, okay? If this is, as I said, if this is an odd number, this value will be minus 1. If this is even number, this value will be plus 1, okay? Minus 1 raised to 5 is minus 1 into minus 2. Minus 1 into minus 2 it is minus 1 into minus 2 it is 2. So this is the answer is D here, okay? The answer is D. You should not write this. You have, if you write this, the answer will be wrong. You have to continue finding cofactor of A32 like this. Remember this part. This is the important part here. Okay. This, as I said, if this addition is even number, the result will be positive one. And this addition is, if this addition is odd number, the result will be negative. Okay. Next example. This is the important example now. So A, what is A? A is equal to what? Minus 1, 5, minus 3 and 2. This matrix is given here, okay? And we have to find adjoint of A. Adjoint of A is to be found here, okay? So in 12 you must have learned this, but it is a very lengthy method. So we have to find it quickly in the exam, so we will use a different method here. Okay, how to find the adjoint of A? This is for 2 cross 2 matrix only, the 3 cross 2 matrix. Next example will be on 3 cross 2 matrix, or example after that. So we'll learn about 3 cross 3 a few minutes after. Okay. So to find adjoint of 2 cross 2 matrix, how to find adjoint of 2 cross 2 matrix? You don't have to do any calculation or anything. You just have to swap these elements. Okay, this element. What is written? These two elements, minus 1 and 2. You have to write 2 here and minus 1 here. What we have done here? We have swapped these two elements. Okay, minus 1 to this position and 2 to this position, and 5 to minus 3. What to do with these elements? 5 should be written as minus 5, and minus 3 should be written as 3. Just we have to change the sign of these elements. Okay. Okay. You understand how to find adjoint of A? This is a simple method. Okay. What we have to do? These two elements should be swapped. Minus 1 should be written here. 2 should be written here. Okay. Minus 1 goes here. 2 goes here. Okay. And these two elements, 5 becomes minus 5 and minus 3 becomes 3. This is adjoint of A. Simple example. Okay. So which option is correct now? 2 minus 5, 3 minus 2 minus 5, 3 minus 1. Okay, this example. This option 2 minus 5, 3 minus 1. Okay, this is easiest possible way to find the adjoint of matrix A. So let us see some other example. Okay, suppose A is equal to 3, 7, minus 8 and minus 9. Okay, how to find adjoint of A? How to find adjoint of A? You do not have to calculate anything or do anything on paper. Okay, so 3 and minus 9, this should be swapped. Minus 9 and 3 goes here. Okay, 3 goes here, minus 9 goes here, and 7 becomes minus 7, and this minus 8 becomes 8. Okay. Okay, this is the easiest way to find adjoint of matrix, 2 cross 2 matrix. This is easiest way. Now adjoint of A for 3 cross 3 matrix. This is a bit difficult. Not so difficult. You don't have to calculate anything on paper or something like that. What we have to do? If we are given here a matrix A, which is a 3 cross 3 matrix. Okay. What is the matrix? You have to write this matrix. So carefully, watch this carefully. You will understand the method. This is easiest way to find adjoint of A. How to find it? It's one. Write this. This first row. Write it as it is. 1 0 and 0. Then 3 3 0. It is 3 3 0. Okay, 3 3 0. Then again 5 2 minus 1. 5 2 minus 1. So what we have done? We have simply written the same matrix again here. Okay. So what we next? Next we will repeat this column, these first two columns again. So what is the first column here? It is 1 3 5. What is the column? First column 1 3 5. We will write it as here 1 3 and 5. Okay. We will just repeat the column, nothing else to be done here. Then again, what is the second column? 0 3 and 2. 0 3 and 2. We don't have to do anything, just repeat the columns again. Now what we do? We will do, we will repeat the first row here again. 1 0 0 1 0. See what we have done here? The first row we have repeated the first row here. Then again we will repeat the second row here. 3 3 0 3 3 3 0 3 3. This is important part because this is not the example that will be asked in exam. Maybe this will be asked in exam, but you will have to find the inverse of matrix. So in order to find the inverse of matrix, you have to find the adjoint of matrix. So this is the easiest way to find adjoint of matrix A. You do not have to go through the road or a transformation or column transformation or any other method, that is a reduction method or anything. This is the easiest way to find A inverse. To find A inverse, you have to you must know how to find adjoint of it. Okay, adjoint of it. So listen carefully. Again, I will repeat this. Okay. Okay, I will repeat this. What we have done here? First, we wrote the matrix again, and then we repeated these two columns again here. Then we repeated these two rows. Now, what we have to do? We have to cancel out this first column and first row totally. Okay, and we have to find the determinant of remaining elements. So consider this matrix here. Suppose this is the matrix. We have to find the determinant of these two elements. Okay, these two elements. Determinant of these elements. Okay, what is the determinant of these elements? 3 into minus 1. It is what? It is minus 3. Minus 3 minus 2 into 0. What is it? It is minus 3. So it is minus 3. Okay. So again, we will next find determinant of these four elements. 0 into 5 it is 0. Minus 3 into minus 1 minus 3. It is plus 3. Okay. What it is? It is plus 3. Then we will find the determinant of these four elements, this matrix, the 2 cross 2 matrix. See, what is it? 3 into 2, it is 6, minus 5 into 3, it is 15. This is 6 minus 15. 6 minus 15, it is what? It is minus 9. 6 minus 15, it is minus 9. Similarly, we will continue like this. Okay. We will find determinant of this matrix. 2 into 0, 2 into 0, it is 0. Minus 1 into 0, it is 0. 0 minus 0, it is 0. Okay. Then we will find determinant of these 2 cross 2, these 2 cross 2 matrix. Okay. Minus 1 into 1, minus 1 into 1, it is minus 1. And 5 into 0, it is 0. So what is the element here? It is minus 1. Minus 1 into 1, minus 1. Okay. Okay. Now what? 5 into 0. We will now find the determinant of these four elements. Okay. 5 into 0, it is 0. Minus 2 into 1. 0 minus 2. 0 minus 2, it is minus 2. Okay. Then what? Then we will find the determinant of these four elements. See, 0 into 0, it is 0. 0 into 3, it is 0. So 0 minus 0, it is 0 again. And determinant of this matrix. 0 into 3 it is 0, 1 into 0 it is 0, 0 minus 0 again 0. Then 1 into 3, 1 into 3 it is 3 minus 0 into 3, 0 it is 3. So this is the matrix, but this is not the adjoint of A. Okay, this is what, how to find it? This is minor of A, minor of A. Okay, this is minor of A. So how to find adjoint of A? How to find adjoint of A? What is the relation between minor of A and adjoint of A? The transpose of this matrix. Transpose of this matrix is adjoint of it. Okay. So we will take transpose. We will take transpose of this matrix. What is the transpose of this matrix? So first, what is the first row? Minus 3, 3 minus 9. We will write it as a column. Minus 3, 3 minus 9. Then 0. So what is the second row? 0 minus 1 minus 2. We will write it as second column. 0 minus 1 minus 2. And again, what is third row? It is 0 0 3. We will write it as third column. 0 0 and 3. So this is what? This is adjoint of matrix A. This is adjoint of matrix. 1 second. This is adjoint of matrix A. So which option is correct here? Minus 3 3 9. Option A. It's okay. Option A is the correct option. This is the proper way, easiest way to find adjoint of matrix A. Okay. This is the easiest way to find adjoint of matrix A. Remember, this is important. Why? Because what is A inverse? The basic definition of A inverse is 1 upon matrix A, determinant of A into adjoint of A. So you will be asked A inverse to find in examination. So determinant of A, finding determinant of A is not hard, but finding adjoint of A with your traditional method is time taking procedure. Okay, it will take you 2 or 3 minutes, but this is the easiest way. This is easy. Okay, next example we will again take this in next example. If you haven't followed this, watch it again in next example. So here A inverse 2 cross 2 matrix is a 2 cross 2 matrix is given here, and we have to find the A inverse. So there are other methods like reduction method or row transformation or column transformation to find A inverse, but those are not feasible methods here. They take too much time, and you do not have that much time in examination, so you have to hurry. So what is A? A is given as 2, 3, 4 and 6. So in the last example we found out adjoint of 3 cross 3 matrix, even, and before that we found out adjoint of 2 cross 2 matrix. So first let me write basic definition of A inverse. What is A inverse? A inverse is equal to what? 1 upon determinant of A into adjoint of A. Okay, one determinant of A into adjoint A. 1 upon determinant of A into adjoint of A. So you have to find two things to find A inverse. In order to find A inverse, you first have to find determinant of A, and then you have to find adjoint of A. So before finding this adjoint of A, we will find determinant of A. How to find determinant of A? What is A given? A is 2, 3, 4, 6. Therefore, determinant of A is equal to 2 into 6. What is 2 into 6? 2 into 6 minus 3 into 4. So what is 2 into 6? It is 12. And 3 into 4 minus 3 into 4, it is 12 again. What is 12 minus 12? It is 0. So what do we call this matrix? It is called singular matrix. Okay. What is singular matrix? No? So determinant of A is equal is 0. That suggests that this matrix is singular matrix. And what can you say if the matrix is singular? If the matrix is singular, then what? We cannot find A inverse. A inverse cannot be found. Also, if you look in this example, we cannot So here we have to, what we have to put here? Here 0. This becomes 1 upon 0, and 1 upon 0 is indefinite. You cannot calculate this 1 upon 0. Okay, that suggests that A inverse does not exist. See, A inverse does not exist. A similar procedure can be applied in 3 cross 3 matrices. If you are given a 3 cross 3 matrix, then what you have to do? Find determinant of A. If determinant of A is 0, then what you have to do? What do you know about it? The matrix A, the inverse of matrix A does not exist. Okay, the inverse does not exist. Remember this. If this value is equal to 0, then inverse of the matrix does not exist. The proper option will be this D, does not exist. Okay, if this, in this example, if this part, if we, instead of 0, if we have found 2, 3, 4, then we have to go on and find adjoint of A. Okay, adjoint of A. We have, so it is not needed here, but still, what is adjoint of A in this matrix? Adjoint of A. How to find? We have already seen this. How to find adjoint of A? What is A? A is 2, 2, 3, 4, 6. So 2 and 6 should be swapped like this. 6 and 2 and 3 becomes minus 3 and 4 becomes minus 4. This is the easiest way to find adjoint of A. Okay. 6 and 2, we have swapped this. Okay, interchange their position. The 2 goes to 6 and 6 goes to 2, and this 3 and 4, they just change their sign. Okay, 3 becomes minus 3 and 4 becomes minus 4. Okay, so here, as because the determinant of A comes out to be 0, the option, the correct option is D, that the A inverse does not exist. Okay, next example. Now we have to find A inverse. Similarly, as asked in previous example, here we also have been asked that inverse of matrix A. What is A? Matrix A is equal to 2, 1, 7 and 4. 2, 1, 7, 4. So as we have already seen, what is the inverse? A inverse is equal to what? 1 upon determinant of A into adjoint of A. Okay. What is determinant of A? What is determinant of A here? It is 2 into 4 minus 1 into 7. What is it? 2 into 4, it is 8, minus 7 into 1, it is 7. 8 minus 7 is equal to 1. Okay. So determinant of A is equal to 1. Now what? So in this formula we have found determinant of A. Now we will find adjoint of A. How to find adjoint of matrix? Adjoint of 2 cross 2 matrix. Adjoint of 2 cross 2. How to find adjoint of 2 cross 2 matrix? So what is A given? A is 2, 1, 7 and 4. What is it? 2, 1, 7, 4. So what we have already seen, adjoint of A is, next we have to interchange the position of these two numbers. 2. 2 goes to the position of 4 and 4 goes to the position of 2. And what happens to these two numbers? 1 becomes minus 1 and 7 becomes minus 7, just like that. What is this? Is adjoint of A. Okay. Now we will use this formula to find A inverse. That is, we have been asked what is the multiplicative inverse we have to find. Okay. So A inverse is equal to what? 1 upon determinant of A into adjoint of A. Okay. What is 1? What is determinant of A? This is determinant of A. This is determinant of A. It is 1. Into what is adjoint of A? Adjoint of A. What is adjoint of A? 4 minus 1 minus 7 and 2. 4, this is adjoint of A. 4 minus 1 minus 7 and 2. What is this? This becomes 1 upon 1. It can be neglected. 1 upon 1 is equal to 1. It can be neglected. 4 minus 1 minus 7 and 2. That is the correct answer. Okay. Which is the correct answer? 4 minus 1 minus 7 and 2 is the D. D is the correct answer. Okay. This is how we find multiplicative inverse of any matrix. This is the formula that you have to remember. Okay, this is the formula you have to remember. So determinant of A, this is easiest to find. And adjoint of A, you must have by now understood how to find adjoint of A. At least for 2 cross 2 matrices. Or what to do to find adjoint of A in 2 cross 2 matrices? You have to swap the positions of these two numbers, and you have to just multiply these elements by minus 1. So 1 becomes minus 1 and 7 becomes minus 7, like that. Okay, next example. Again, the inverse of the matrix. Okay, again, similar example, just okay, we will see what to do later. First one, right? A is equal to what? It is given 3 minus 2, 1 and 4. 3 minus 2, 1, 4. 3 minus 2, 1, 4 it is given. So first we find determinant of matrix A. What is the determinant of matrix A? It's 3 into 4. 3 into 4 it is 12 minus 2 into 1 it is what? Minus 2. 12 minus minus 2. What is 12 plus 2? What is 12 plus 2? It is 14. Okay. Determinant of A is equal to 4. Okay. Now we will find what? Adjoint of A. Adjoint of matrix A, that we have to find now. Okay, again I will write the standard formula. What is A inverse is equal to 1 upon a determinant of A into adjoint of A. So we have already found determinant of A. What is remaining? Adjoint of A is remaining to be found. And we will find adjoint of A. What is A here? A is equal to 3 minus 2, 1 and 4. It is 3 minus 2, 1 and 4. Therefore, what is adjoint of A? Adjoint of A is, so this 3 and 4, they will swap their places. So 3 goes to the place of 4 and 4 comes out to the place of 3. So it becomes 4 and 3. Okay, 4 and 3. So 3 goes to 4, 4 comes to 3. So minus 2 will be 2 and 1 will be minus 2. Okay. Okay. Now A inverse is equal to, formula suggests that A inverse is equal to 1 upon determinant of A into adjoint of A. It is 1 upon, what is determinant of A? It is 14. 1 upon 14 into adjoint of A. Adjoint of A, this that we found here. Adjoint of A is 4, 2 minus 1 and 3. 4, 2 minus 1 and 3. 4, 2 minus 1 and 3. So, but such options are not given here. Okay, such options are not given. What we will do? We will multiply this 1 upon minus 14 to each element inside the matrix. Okay, now what it becomes? 4 upon 14 and 2 upon 14 minus 1 upon 14 and 3 upon 14. So this is the correct option. Which one is correct now? 4, 2 minus 1, 3. This. So A. Option A is the correct option. Okay. So this is how we find inverse of 2 cross 2 matrices. You just have to remember this formula. Determinant of A you should find, and adjoint of A, as I have said, you have to find like this. Now this is example. Okay, what is A here? So this is a special case in matrices. Okay, so We will take a general example here. Okay, A. If A is given as A 0 0 0 B 0 and 0 0 C, then A raised to n. What is A raised to n? It is A raised to n 0 0 0 B raised to n 0 and 0 0 C raised to n. Okay. No matter what number is given here, you have to take the power of this number. Okay? A raised to n, B raised to n, C raised to n. If the matrix given is like this, just diagonal entries are there, all the non-diagonal entries are 0. If the matrix is like this, then you have then A raised to n is equal to this A raised to n 0 0 0, B raised to n 0 0 0, C raised to n. For example, if we are considering any example, then it is suppose 2 3 4 0 1 3 0 0 3. Sorry, 0 0. Okay. Such matrix is given. All the non-diagonal entries are 0 and only non-zero entries are diagonal entries. Then if you are asked to find a cube, what you have to do? You just have to find 2 cube 0 0 0 1 cube 0 0 0 3 cube. That is your answer. Okay. What is a cube? Then 2 cube is equal to 8, 1 cube 1, 3 cube 27. Okay. So that will be the answer. So in this example, what you have to find? You have to find A inverse and similar diagonal matrix is given here. Okay. So what will be actual answer? A inverse will be, rather than A we will write A inverse. Then it is 0 0 0 B inverse 0 0 0 C inverse. Okay. What is, so you cannot see this in any of the options. So what is A inverse? It is 1 upon A 0 0 then 0 1 upon B 0 0 0 1 upon C. Okay. So which one is the correct answer here? D. D is the correct answer. Okay, remember this. Now again similar example. Okay, what is A here? A is A 0 0 1 upon B. Okay. Again also here only diagonal entries are non-zero, all other entries are 0. So this entry is 0, this entry is 0. Only diagonal entries are non-zero. So how do we find A inverse? A inverse. How do we find A inverse? We will find so A inverse 0 0 1 upon B inverse. Okay, that is, you just have to find it. This is minus 1. You just have to put minus 1 here. If a cube is asked, you should take cube of these numbers over here. Okay. If fourth power is asked, you should take fourth power of these elements. Remaining element will be 0. Okay. So what is A inverse? So such example, such answer is not seen in the example. Okay. Such option is not given. Okay. So what is A inverse? It is 1 upon A 0 0 and 1 upon B inverse means what? It is B. 1 upon B inverse means B. 1 upon B inverse, that is B upon 1. What is B upon 1? B upon 1 is B. So this is the correct option. Which one is it? C. C is the correct option. Remember this. If only diagonal entries are given, all other entries are 0, then how do we find A inverse? No matter what you have to find, A inverse or maybe A square or A cube or A raised to 4, no matter what, we have to take the power. If square is asked, you have to square these elements, square of these elements. If cube is asked, you have to take cube of these elements. Okay, and similarly like that. Now inverse of these matrices. You know how to find inverse of these matrices. You must have learned this in 12th. Okay, but that is very lengthy method. You two or three methods are there actually. Which one are those? Column transformation, row transformation, or reduction method you use. Okay, but that is not needed here. Those are very lengthy methods. So as we have already done, what we will do? What is how to find A inverse? A inverse is equal to 1 upon determinant of A into what? Adjoint of A. Okay. A inverse is equal to 1 upon determinant of A into adjoint of A. So we will first find determinant of A. What is determinant of A? What is A here? A is equal to A is equal to 3 minus 2 minus 1 minus 4 1 minus 1 2 0 and 1. Okay. What is determinant of A? So this element first we should consider 3 into then determinant of this two element 1 into 1 1 minus 1 into 0 0. Then this element what? Minus of minus 2 into what? Minus 4 into 1 minus 4 into 1 minus 4 minus 2 into minus 1 2 it is 2. Then again minus 1 it is plus minus 1 so it becomes minus 1 minus 1 minus 4 into 0 it is 0 minus 2 into 1 2. So what do we find? 3 into 1 what is it? Minus 4 into plus 2 what is minus 4 plus 2 is minus 2 into minus 2 plus 4 it is minus 4 it is minus 4 into what it is minus 1 0 into minus 2 it is minus 2 3 into 1 3 minus 4 minus plus 2 what is it so 3 plus 2 it is 5 and minus 5 minus 4 5 minus more 4 it is equal to what is 1 so determinant of a what we got determinant of a is equal to 1. Now we will find the remaining. Okay. Now we will find adjoint of A. How to find adjoint of A? First we will write the given matrix as it is. 3 minus 2 minus 1 minus 4 1 minus 1 2 0 and 1. And again we will repeat these first two columns. What is the first column? 3 minus 4 2. We will write here 3 minus 4 and 2. What is the second column? Minus 1 minus 2 1 0 minus 2 1 and 0. So we'll write it like this. Then again, what is the first row? We will repeat the first row below all these three lines. Okay, what is the first row? 3 minus 2 minus 1 3 minus 2. We will repeat it like here. 3 minus 2 minus 1 3 minus 2. Then again, what is the second row? Minus 4 1 minus 1 minus 4 1. Okay. Now what we have to do? We will delete first row and first column. We will delete this first row is deleted and second row first column is deleted. And we will take determinant of all other elements. Okay. Okay. What? So this is first we will take determinant of these elements. 1 into 1 is equal to 1. 1. So and 1 into 1 is equal to 1 minus 1 into 0 it is 0 1. 1 minus 0 it is 1. Then again determinant of this element minus 1 into 2. What is minus 1 into 2? It is minus 1 into 2 minus 2 minus minus 4 it is plus 4, 4 minus 2 it is 2. Then again determinant of these 4 elements, minus 4 into 0 0, minus 2 is what, minus 2. Okay, then again, then what, then determinant of these 4 elements, 0 into minus 1 it is 0, minus 1 into minus 2, minus 2 minus minus 2 it is plus 2. Okay, this plus 2. Then again determinant of these 4 elements, what is the determinant of these 4 elements, 1 into 3 is equal to 3, 1, this 1. Okay, 1 into 3 is equal to 3, minus 2 into minus 1. 1 into 3 is equal to 3, minus 2 into minus 1, minus 2. 3, that is 3 plus 2. What is 3 plus 2? It is 5. 3 plus 2 is equal to 5. Then we will find the determinant of this matrix. Okay, 2 into minus 2 it is minus 4. Minus 4 minus 0 into 3. 3 into 0. What is 3 into 0? 0. So this is minus 4. Similarly, we will find the determinant of these elements. We will continue like this. Minus 1, minus 2 into minus 1. It is minus 2 into minus 1. It is 2. Minus 1 into minus 1. Minus 1. Okay. 2 minus 1 it is 3. 2 minus 1 it is 2 plus 1 it is equal to 3. And similarly we will find the determinant of these two elements. Minus 1 into minus 4 minus 2. Wait. See, minus 1 into minus 4 it is 4. Minus 1 into minus 4 it is 4. Minus 3 into minus 1 minus 3 it is 4 plus 3 is equal to 7. So therefore this is 7. Now we will find the determinant of this matrix. 3 into 1 it is 3, minus 2 into minus 4 it is 6. 3 minus 6 it is minus 3. Okay. Okay, we will do this again. 3 into 1 it is 3. 4 into, sorry, this is not 6, this is 8. 3 minus 8 is 8, it is minus 5. Okay. Let me delete most of this part. So that's how to find. Okay, what we have found? This is minor matrix, cofactor matrix actually. So, cofactor matrix. Therefore, we have to find adjoint. What is adjoint of A then? We have to take transpose of this matrix. So, what is it? What is the first row? 1, 2, minus 2. We will write it as column. 1, 2, minus 2. 1, 2, minus 2. Then second row, it is 2, 4, 2, 5, minus 4. 2, 5, minus 4. What is third column? What is third row? It is 3, 7, minus 5. We will write it as column 3, 7, minus 5. Okay. Let me erase this first. So this is our adjoint of A. Now what is standard definition? A inverse is equal to 1 upon determinant of A into adjoint of A. 1 upon determinant of, what is determinant of A? It is 1 that we found initially. 1 upon 1 into adjoint of A. Sorry. We will write adjoint of A directly. One upon one into adjoint of A. What is adjoint of A? 1, 2, 3, 2, 5, 7, minus 2, minus 4, and minus 4. So what is 1 upon 1? It is 1. So it is 1. So we don't have to consider it. So this is the answer. Which one is? Which one it is? 1. So 1, 2, 3. So 1, 2, 3. Here 1, 2, 3 you can see, and here 1, 2, 3. 2, 5, 7. So here not, it is not 2, 5, 7. This is 2, 5, 7. Let us check third row. Minus 2, minus 4, minus 2. Minus 2, minus 4, minus 4. So this is the right answer. See, okay. This is how you find inverse of the matrix. You have to consider these two points first: determinant of A and adjoint of A. Adjoint of A, I have already told you how to find adjoint of A. Yes, 3 cross adjoint of 3 cross 3 matrix is a bit difficult than 2 cross 2 matrix. 2 cross 2 matrix you can find easily. Next example. So here we have given this different type of problem. Okay? We have given here a matrix A, and what we have said, A inverse is equal to 1 upon K plus adjoint of A. So as we have previously seen in this example, what is this looks like the standard definition. Okay, standard formula. What is it? A inverse is equal to 1 upon determinant of A into adjoint of A. So this is A inverse, this is A inverse. Adjoint of A, adjoint of A. That means what? This is 1, here it is. That is what? K means what? Determinant of A. Okay. What is K? K is determinant of A. So what we have to find? We have to find determinant of A. So what is A? A is equal to 3, 2, 4, 1, 2, minus 1, 0, 1, 1. Okay. So what is determinant of A? What is it? Sorry. What is determinant of A? First we consider 3 into 2 cross 1. 2 into 1 is equal to 2, minus 1 into minus 1, that is plus 1. It becomes plus 1. Minus 2. This element minus 2 into bracket 1 into 1, it is 1, minus 1 into 0, it is 0, plus 4. This is 4. So 1 into 1, it is 1, minus 2 into 0, it is 0. So 3. 2 into 1, 2 into 2 plus 1, sorry, 2 plus 1 is equal to 3. 3 into 3, it is 9. Minus 1 minus 0, it is 1. 2 into 1, 2 into 1, 2. 9 minus 2. Plus 1 minus 0 is equal to 1 minus 0. 1 minus 0 is equal to 1. 4 into 1 is equal to 4. So what is the answer? 9 minus 2 is equal to 7 plus 4 is equal to 11. So this is the correct answer. Okay, you don't have to find this everything. Okay, what we compare this with standard formula. Okay, A inverse is equal to 1 upon determinant of A into adjoint of A. What does it say? A inverse, A inverse. Here adjoint of A and adjoint of A. So which means K is equal to determinant. Okay. Next example. So here we have to find A inverse. Okay. A inverse. What is the definition? What is the formula for A inverse? 1 upon determinant of A into adjoint of A. So we first have to find determinant of A. What is A here? A is equal to 2, 3, 4, and 6. So determinant of A is, what is determinant of A? 2, 3, 4, 6. What is determinant? 2 into 6 it is 12 minus 3 into 4 it is 12 is equal to what? 0. So similar example we have solved earlier. So here 0. So this becomes 0. 1 upon 0 it is indefinite. So therefore what we say? A inverse does not exist. A inverse does not exist. Okay. Okay. Let us say next example. So here product. You must have learned product in 11th standard or 12th. Okay. A. What is A here? A is equal to 1 minus 2, 1. 2, 1, 3. B is equal to 2, 3, 1, 1, 2, 1. Okay. We have to find what we have to find here. We have to find AB transpose. Transpose of AB. So that is, we first have to find AB first. AB has to be found first. What is AB then? AB is equal to. So see, we first need to understand if the multiplication is possible or not. So we will write the order of this matrix. What is the order of this matrix? First we will write the rows. How many rows are there? 2 rows. How many columns? 3. Here 3 columns and 2 rows. No, 3 rows and 2 columns. So what I had said earlier, this is 3 and this is 3. If these two numbers are equal, then only multiplication is possible. So as these two numbers are equal here, the multiplication of these two matrices is possible. Now we will multiply these two matrices. So and so see, we will take first row and first row of first matrix and first column of second matrix. So first row, first column. So 1 into 2 it is 2 plus minus 2 into 3 it is minus 6 plus 1 into 1 it is 1. 1 into 1. 1 into 1 it is 1. Then we will take first row and second column. First row of first matrix and second column of second matrix. First row, second column. 1 into 1 it is 1. Minus 2 into 2 minus 4 plus 1 into 1 it is 1. Then we will see the second row, first column. Second row and this first column. Okay. This second row and first column. Second. 2 into 2 it is 4. 1 into 3 it is 3 plus 3 into 1 it is 3. Okay. Then we will take second row and second column. What is second row? This second row and this first column. Okay. 2 into 1 it is 2 plus 1 into 2 2 plus 3 into 1 3. Okay. This is product of matrix A and B. Okay. What is the product there? 2 plus 1 2 plus 1 3 3 minus 6 it is minus 3. Okay. Then 1 minus 4 1 it is 1 plus 1 1 plus 1 2 2 minus 4 minus 2 4 plus 3 plus 3 it is 10 and 2 plus 2 plus 3 2 plus 2 4 4 plus 3 it is 7. So what is it? This is AB. This is not our answer. Okay, this is AB. What we have to find? We have to find AB transpose. Okay, what is AB transpose then? How do we find transpose? Okay, this first row should be written as first column here. Second row should be written as second column. That is how we find AB transpose. Transpose of any matrix for that matter. So it is my first row is minus 3 minus 2, then minus 3 minus 2. What is the second row? It is 10 7. So we will write it as second column 10 and 7. That is our answer. Okay. Let us see if the answer is in options or not. Minus 3 10 minus 2 7. Okay. This one is the Correct answer. Okay. AB transpose. Okay. Next example. Okay. Omega. If what is the question here? If omega is a complex cube root of unity, what is omega? Omega is equal to complex cube root of unity. Okay. Complex cube root of unity, and a is equal to, what is a given here? A is equal to, that is, omega cube is equal to what? Complex cube root of unity. What does it mean? Cube of omega is equal to 1. So what is a? Omega 0 0 omega, and we have to find a raised to 50. We have already seen this. Again here, diagonal elements are non-zero and all other elements are 0. So what is a raised to 50? It is simply omega raised to 50 0 0 omega raised to 50. Okay, omega raised to, so we have to take power of only these elements, not these elements. Okay, only these elements, omega raised to 50, omega raised to 50. Is this in the option? No, the options are very different from what we have found here. Okay, omega raised to 50. But we know that omega cube is equal to 1. So we will convert this omega raised to 50 in this form. Okay, what is omega raised to 50 means? Omega raised to 48 into omega square 0 0. Again, omega raised to 48 into omega square. Okay, how can we write this? The index formula. Okay, omega raised to 48 plus omega square. So 48 plus 2 is equal to what? It is 50. Again, similarly like this, 48 plus 2 is equal to 50. Again, what we will do? Omega raised to 48, we can write it as omega cube raised to 16 into omega square 0 0, and omega cube raised to 16 into omega square. Okay, you can write it like this. But what is omega cube? Omega cube is equal to, omega cube is equal to 1. Therefore, this becomes 1 raised to 16 into omega square 0 0, 1 raised to 16 into omega square. This becomes, what is 1 raised to 16? It is 1. That is omega square 0 0 omega square. Okay. Omega square 0 0 omega square. So this, again, this is not in the option. Okay. So what we have to do? Take omega. See, we can take omega outside the matrix. What will remain inside? If we take omega outside the matrix, omega 0 0 and omega. See, omega into omega is omega into omega, omega square, omega into 0 0, omega into 0 0, and omega into omega, omega square. So you can take it outside. So, but what is this matrix? See, this is omega. But what is this matrix? This whole matrix. What is it? It is A. Omega A. The answer is omega A. See, the answer is omega A. You should not be confused with omega square A. If you take, see, we will see about it. So you should not be confused with omega square A. If you take omega square outside the matrix, what remains inside? It is 1 0 0 and 1. Okay. If you take omega square outside, 1 remains inside. If you take omega square outside, 1 is remaining inside. So 1 0 0 1. This is identity matrix. If the question, the answer was like this, one of the options, then this would have been your answer. But answer is not given like that. Therefore, the correct answer is this, omega A. Now the A is given and you have to find A square. Remember, so this matrix, if looks like a diagonal matrix. Okay, it looks like a diagonal matrix, but it is not a diagonal matrix. Diagonal. What is a diagonal matrix? These entries, these are the entries that should be non-zero entries. Okay, that should be some numbers, some non-zero numbers. Okay, okay. So we are given a. A is equal to what? 0, 2, 2, and 0, and we have to find a square. So here you do not have to think a lot. You just have to find a into a into a. What is a into a? 0, 2, 2, 0 multiplied by 0, 2, 2, 0. You will find the multiplication of this matrix. Okay. So first row and first column, 0 into 0 it is 0, 2 into 2 it is 4. Again, first row, second column, 0 into 2 it is 0, 2 into 0 it is 0. Then second row, first column, 2 into 0, 0 into 2 it is 0 plus 0 again. And here 2 into 2 it is 4 plus 0 it is. So what is the resultant matrix here? 0 plus 4 it is 4. Here 0, and 4 plus 0 it is again 4. So this should be your answer. Okay. So the correct answer is here D. D is the correct answer. You should not be confused with this one or any other option. The correct answer is this. Also, the answer could be written as 41001. That is 4I. This can be also your answer. If this is given in exam or your options, this would be your correct option. Okay. Next example. Nothing to be solved here, is just the basic definition. If A and B are non-singular matrices, then what is the correct option here? This. This is okay. These are this is one of the properties given in your textbook. Nothing to be solved here. So AB inverse is equal to B inverse A inverse. So here also it is given AB inverse is equal to A inverse B inverse. This is not the correct answer. This is the correct answer. Okay. Matrix multiplication is not like some multiplication of our regular real numbers or anything. Okay, it is different from that. This part is also not true. It is matrix multiplication is not commutative. So AB is not equal to BA. Okay, next again. So this is also an example of matrices. You must have solved this with reduction method. Okay, reduction method. But here you do not have to go with matrices. Just use the age-old method. 2y x plus 2y is equal to 3. 2x plus 3y is equal to 4. Yeah. This is a simple example. You can solve it uh, by making this coefficient same. You have to multiply this equation by 2. I'm not going to solve this. You can solve this. You have learned this in 10th standard. Okay. So here, in next example. So we have given x. What is x? X is equal to minus x minus y z and t. Okay. What do we have to find? We have to find transpose of adjoint of x. Adjoint of x. Okay. So that means we will first have to find adjoint of x. What is adjoint of x? Adjoint of x. What is adjoint of x? So we have seen such examples earlier. Okay. Adjoint of x is you have to swap these two elements. Okay. You have to swap these two elements x minus x and t. So t comes here, minus x goes here. This minus y becomes y and z becomes minus z. This is adjoint of x. Okay, this is adjoint of x, and that is not our answer. We have to find transpose again. Then what is transpose? Adjoint of x, and it is transpose is to be found here. What is transpose? So first row should be written as first column ty. It becomes t and y. and second row becomes second column minus z minus x. So that is transpose. So what we have been asked, we have found transpose of adjoint of x, transpose of adjoint of x, transpose of adjoint of x. This is the correct answer. Where is it? It is t minus z y minus x. So this is the correct answer. Okay. There are few examples left. We will take in next session.